Alright, so I'm going to jump to the table in just a second, but I've gone and taken the JK diagram, swapped it for D flip-flops, and I've left these in place because I know that they're going to want to stay in this order when we go to D flip-flops, but let's verify that in a second. So what's nice about the D flip-flop is we have the present state. Oh, and actually I need to unhide these. So we have the present state and the next state, which nothing changes. We're in there this time because we're designing the same counter. The only thing we're changing is instead of being using JK flip-flops, we're using D flip-flops. And the excitation table for the D flip-flop is very straightforward because the new value of Q, the way the D flip-flop works, the new value of Q is always the D value that you plug in. So since the D value is the same as Q plus, you can get away with simply copying and pasting this over. And so again, now these are going to hide, but then this time the D flip-flops are a function only of the present state. Well, again, they were last time as well. But once you have this written down, the D flip-flops are going to be controlled entirely by the present state that we're looking at. So now I'll jump over to the Kmaps. Okay, so now I have a fresh set of Kmaps. Again, the flip-flop inputs are going to be controlled by these present states, so we'll just fill it in order. So this time we get 1, 0, x, 0, 1, oops, down here it's 1, x, and then 1, 0. Then D1 goes 0, 0, x, 0, 1, x, 1, 1. Then D0 goes 0, 0, x1, 0x, oops, 0x, 1, 1. Okay, and because of this particular counter that we're looking at, these expressions turn out to be very straightforward. So let's construct those. So again, this Kmap turns out to be fairly easy to circle. Oops. And we have 3 1s that we need to circle there. 3 1s, we can get them in this group of 4. And then 3 1s again, we get them in this group of 4. And so that means that D2, we can say it's equal to Q0 bar. D1 is equal to Q2. And D0 is equal to Q1, I think. Yes, Q1. And so now we just build that in Logisim. So I will put that together real quick. And so then the D flip-flop constructs this beautiful construction right here. And so that's just because of the particular counting structure that I made. In general, there's some function between the various Q's and the resulting D lines. But I did show some examples of that. So I really wanted to focus in on one particular straightforward example that I could go fairly quickly, but still describe all of the pieces one more time. So I hope this helps your preparations and that clarifies some things. And I will be adding some videos in just a little bit with a more in Mealy design.